Power consumption is an important consideration for gadgets that run on battery. Between the two similar-sized Arduinos, the Due and the Mega 2560, which one is more nimble in terms of power consumption? Is it the Due with its 32-bit 48 MHz 3.3V processor, or the Mega 2560 with its 8-bit 16 MHz and 5V processor? Let's find out. In this lecture, what I'd like to do is to compare the power consumption between the Arduino Due and the Arduino Mega, which is particularly useful if you are thinking of using one of these boards in a battery-powered application. So power consumption then becomes an important factor. Not comparing any other aspects of these two boards, especially their computational capabilities, so taking everything else as being equal, which of these two boards is more efficient in terms of using power? To drill into this question, I will be executing the same sketch on both boards. Simply, this sketch will take a reading from analog pin 0 and then do a quick calculation and print the voltage out to the serial monitor. First, I will connect the boards to my computer and upload the sketches. Then I will remove the USB cables and power them from a separate power supply, which can give me an indication of how much current each board draws. So I will upload the sketch first to the Due. So I'll connect the Due, and it's already selected in the IDE, so I will upload the sketch. Done uploading, so I'll remove the USB cable from the Due and plug the Mega in. And repeat the process. Select Arduino Mega, and okay, there's the port, and upload the sketch. All done. So unplug the Mega from the computer as well. All right. So next, I have each board connected to a power supply, and there is the power supply. Let's just zoom into it. So I've connected power to the two boards by connecting jumper wires to the V-in and ground pins. Remember, the V-in pin for every Arduino board is connected directly to the power subsystem to which the battle connector is connected to. So this is going to go through the voltage regulator on the board as well. It's the same thing as plugging power, external power to the board via the battle connector. So I've done the same thing for the Arduino Mega. The Arduino Due is connected to, just separate the wires, is connected to the power supply on the left, and the Arduino Mega is connected to the power supply on the right. So I will turn on the power supplies, and they're both calibrated to 12 volts voltage and a maximum of 500-900 milliamps. Let me make those the same actually. So on this side, I'll turn that to 500. It's not going to reach that amperage anyway, but just so that we've got the settings absolutely the same for both power supplies. And I'll turn them on and wait for a few seconds for power to settle, and then they make the comparison. So turn it on, turn it on. Both boards are now running, and that's stable enough. So what we can see is that the Arduino Due is drawing about half the current that the Arduino Mega is. So 0.057 amps versus 0.101 amps, that's stable now. Almost double. The Mega is consuming almost double the power that the Due is consuming, even though the Due is a more powerful microcontroller. So this is something to take into account. Based on this test, the Arduino Due is a more economical choice for a battery-powered application when compared to the Arduino Mega. Of course, you could reduce this power consumption further if you make your own custom power supply design. You can bypass the voltage regulator by plugging regulated 3.3 volt power into the 3.3 volt pin here. You can do the same thing with the Arduino Mega, of course. You can plug power directly into the 5 volt pin. Just be careful. This power will go directly into the microcontroller unregulated on the board, so you need to be sure that you are doing proper regulation before you supply that voltage to the board. Okay, let's move on to the next thing, which is playing around with debugging on the Arduino Due.